All right, guys, let's get into section 10.1. Hopefully this is relatively quick. Find out. So this is from chapter 9. And I said this on a few of my handouts. It says this in the title of the chapter. Chapter 9 is all about one sample information. One sample mean, one sample proportion. Make sure you guys are with me. There was a problem where I talked about a new drug for pain reliever for statistics students. Did we do that problem? Or is that on the, I think it's on the practice test. Why is this sort of not the complete picture for a lot of things we do? Because how would you test a brand new drug? How would you test it? How would you set up? You guys know this. You know how you would do it.
You'd have a control group. You'd have two groups. You'd have one with getting the medicine, and then another sample that gets a placebo.
Okay.
Or nothing.
I love it. So, to be really honest, you would have three groups. You would have one that gets the actual medication, one that gets a placebo, and a third that don't get shit. And we just say, good luck to you guys. Right. What's the whole thing? Everybody know what a placebo is? Sugar pill, yeah. They can make it look all kind of nifty, make it look like an amazing gobstopper. So, you know, your brain thinks it's doing something, so guess what? Your brain makes something happen. It's amazing. So if you're trying to say you have a new drug that's better or does great things, you got to show it's better than just a placebo. It's better than what the brain can do by itself. You guys with me? So really, you have a third group normally that just gets nothing, just so you can see, is there something that changed in the universe that made everybody better? Because that would be what if they got better too, you're like, wait a minute, everybody got better. What happened? You guys all kind of with me. So let's focus on this, because we can only handle two at a time instead of one. So let's say we set it up like that. We have one group that gets the placebo and another group that gets the real medication. Everybody with me? Do we know a damn thing about this medication? No, we don't know shit. In fact, I keep pointing to you guys, so you're my sample that's going to get the real drug, right? So I'm hoping, hey, you might get better, you might die. Good job. And then you guys are all getting a sugar pill, so if you die, you're going to die anyway. So it's not the problem with the sugar pill. Is everybody with me? And you guys are just watching. You're all recording stuff for me. What am I going to be able to see? I can find, I'm not going to get too specific. Let's say I'm looking for a certain effect. So I can see an average effect that these guys have, be it pain relief, be it reducing inflammation, be it growing hair, whatever the hell, right? So I can measure what these guys experience, and I can measure what these guys experience. All that data is what kind of data? They are coming from samples. So I'm not going to have this. So it's like I'm not comparing it to some known previous thing or some expected normal thing. I'm not comparing it to some grand amount. I have no idea what that grand amount is. Okay, so, which means, how many symbols up there right now indicate a sample? How many samples are represented in that equation? One, beautiful. There's an X bar from one sample, and there's an S from a sample. And what did we just discuss? We need something that could handle two. It's amazing. It's amazing, right? So what's going to happen? This is almost too nice to believe. What's going to happen is everything's going to double in this. So for chapter 10, when I'm dealing with two samples, let's be very specific. Two sample means. And if X bar 1 minus X bar 2 minus, I'm just going to jump to the chase here a little bit. Now here's where things get, I always love it when I say this because it was like, dude, you passed that point. Here's where things get interesting. All right, can somebody, let me just write this. We've done something like this before. This piece, couldn't I write this piece like this? We've done something like that before, right? So pretty cool with that. Square root of s squared is s, because s is positive, so it's just going to equal s. So now watch what I can do then. So this becomes, square root of s1 squared over n1 plus s2 squared. I just doubled everything. Those are the same formula, I just doubled everything. It's okay if you don't share my neuropathy or whatever it is, but they are the same formula, believe it or not. Now watch. The most common thing to happen, let me make sure you guys are able to, what does this measure right here by itself? X bar 1 minus X bar 2. What would that mean? That would be, you guys are group 1, you guys are group 2. X bar 1 would be the sample mean effect for you guys, and X bar 2 would be the sample mean effect for you guys. Are you with me? Could be the average amount of time it took for you for the swelling to go down or something, right? I guess. Okay. So this represents how different those two were, right? If this is 0, then I'm not going to do the test. I mean, they both have the exact same, so you're no better than a placebo. Way to go with your new drug. What'd you do? Just put sugar in there? Yay. Right? Yes? So this is how different period they were, but we know in statistics that's not good enough. If two things are 80 apart, are they very far apart? I love this question. If two numbers are 80 apart, are they very far apart?
80 what?
Just 80. Two numbers are 80 apart. Are they very far apart?
Depends on the scale.
Depends on the scale, which is set up by the standard deviation. If I said the standard deviation was 80, then 80 apart is just one step. It's not very far. But if I said the standard deviation is 4, screw it. They are way the hell apart. Are you guys with me? So this is a relative. Now, when I divide by, this is kind of an attempt to figure out what the whole standard deviation is by putting both of them together. But again, I just doubled everything that was in my original equation. So this is a relative distance between the sample means. How relatively different were they? So again, I could do a hypothesis test and see, was the difference I saw enough? So if these guys, their swelling went down in 9.2 minutes, and you guys, your swelling went down in 9.3 minutes, we don't know the standard deviation, but right on the surface, that doesn't sound like it's different enough. And that's the whole idea of hypothesis test. Is it different enough? So this would be the formula for step 4, right? Figuring out what T star is. Now, one thing that's almost always true, it will definitely be true for the ones I gave you in the homework. What are we fighting against? If I built this new drug, I love it, created this new drug, what am I kind of fighting against? So you guys got the sugar pill, you guys got the real drug. Somebody who doesn't think my drug works, what would they think? That I'm going to end up seeing? Yeah, I'm going to end up seeing the same effect, right? That's what they would say. So I'm fighting against the idea that mu1 equals mu2. That would be the null hypothesis, that your drug has no special effect. Or maybe even a detrimental effect, but that's neat. So then what's mu1 minus mu2 almost always? If this is mu1 equals mu2, mu1 minus mu2 would be 0. So then my formula really is just this piece. Now in reality, you could have a hypothesis where you say, well, the average time here is 2 minutes more than there or something, but we're not going to get that deep into this, for damn sure. Okay, so this is how step 4 would not change, but the formula's got to use. So for percentages, I had to use p-hats and stuff. For 2 samples, I have to use the formula that's got room for 2 samples. What does N2 mean? Sample size for a group 2. It's amazing, right? So they have to give me all this information. Okay, maybe. So here's another thing that's going to change. So if my claim is my drug is faster than the old drug, than a placebo. Let's say. I don't even know. That doesn't even make sense. I don't care. Here's the thing. I'm not comparing a sample to some known amount. So my hypothesis statements won't have any numbers in them. So let me do it better. Erase that, Clay. Let me do it better. Girls average higher than boys. Right? Let's say that's a claim. And let's say the girls are group 1 and boys are group 2, just because. So then my claim would be that girls' average is higher than the boys' average. Do you see what I mean? There's no numbers there. I'm not comparing it to some, it's known to be 80. No, I don't know shit. I'm just making a claim about the relative position of both groups. Where would that go? HO or H1? Yeah, because there's no equal sign. See, I mean, the fundamentals of the test don't change. Some of the specific details change. No equal sign goes here. What's going to go into HO? Get out of there with that. I'm thinking ahead. What's going to go into HO?
Less than or equal to.
Yeah, less than or equal to. So how many tail tests will it be? One tail test. I like it. The second step, this is where things get weird. In this problem, I'm going to have to use t-scores, right? I'm going to give you problems where they only give you the sample standard deviation, which is really, really, really true to life. Which means how do I look up a t-score? What's the very first thing I got to figure out before I even look at the chart? Degrees of freedom, which is n minus 1. Where does that kind of break down immediately? How many n's do I have? I've got 2 samples. I got n1 and n2. Now, the book, and actually I'm not saying just the book, Reality has this remarkably disgusting formula in cases where I don't know if sigma 1 equals sigma 2, and they have this ugly formula. All right. And then I love it in the book that actually says, but technology can do this easily. And then, you got me, so too damn bad. But if I did know those were equal, and this is the one we're going to use, it's close enough, is the degrees of freedom will be n1 plus n2 minus 2. Now, does that make some kind of sense? If I had 1 sample, it's n minus 1. Well, I got 2. If you add those together, you get n1 plus n2 minus 2. That basically is where that comes from. It's really can only be used in certain situations, but I'm going to let you use it everywhere in this section 10 homework, just because. You got me, so I'm trying to be nice. I don't know, I'm not used to it. All right. So on step 2, you do those degrees of freedom. You look it up in the chart. You set up your rejection regions. Step 2 doesn't change beyond that. Degrees of freedom, right? I'm sorry, not step 2, step 3. Step 2 doesn't change because it's just do I use z-scores or t-scores. So step 2 doesn't change. Step 3 changes a little tiny bit. Step 4 changes, a decent amount, I guess. Right, this is how you calculate your t-star. And then the conclusion is the same, same way, same as always. In this case, my conclusion, would it be reject or support? Which language would I use? Yeah, my claim was the H1, so I'm going to use support. Either I support it or I fail to support it. Okay, I like it. Okay. Maybe. Now, the thing I didn't want to say before saying all this is this. You're going to be really happy. I might even get some smiles, which is going to be a first for today. Let's go ahead and make section 10.1 extra credit.
Oh shit.
Oh, you can clap, man. It's going to make me feel like... No. Stop clapping right now. Because I'm going to come back with some extra shit later. You're going to make me feel like, I did too much good stuff. Let me kind of counteract that. Deal with it. This is the way it is. All right. So, let's make the formula sheet. I'll give you the answer key for the test, and for the practice test, and then we'll see if you guys have questions. So if you don't want to do the extra credit, don't put this on the formula sheet. It's that simple, right? There will be a problem on the test from section 10.1 in case you did the extra credit. Yeah,
You meant the homework is extra credit, right?
10.1 is extra credit. Yes.
The homework?
The homework, yes.
Ah, cool.
Yes. I'm not sure what else I would be talking about.
I thought you meant just one problem.
No, section 10.1 is extra credit. Yeah. All right. So, it just felt so weird to get applause. I had to stop it because I'm used to making people cry and shit. I'm not saying I like it. I hate it when I make somebody cry, but I actually made people cry in my career. It's the worst thing in the world. Unless I can tell they're just fake crying and I'm like, screw you guys. So, this test is going to start back with chapter 8. Confidence intervals, right? So it's going to be those 5. Everybody, what's happening? Yes?
You need to give out the answers.
I will. Not right now. After I'm done with this. So there's going to be those 5 equations that were on the quiz today. With this guy. This guy. This guy. This guy. This guy. Does anybody remember, somebody asked me about this earlier, there's an actual homework problem where they ask you to do this, but they don't tell you what these are. What do you assume these are if you don't know? 50-50, right? Now, very quickly, if anyone's curious about this, mathematically, making these 0.5 and 0.5 makes n the biggest it could be, which makes sense. What do we do in statistics when there's a piece of the thing I don't know? I kind of punish myself for that. I make things worse for myself. So I'm going to make the sample I need to take bigger in the case I don't know shit about these guys. And if you're at all curious, I don't know if you guys remember this from algebra. Do you remember those problems where they said Farmer Dave wants to make something to have for his pet pig and his little pen? What's the maximum area he can have? Does that sound familiar to anybody? Yeah. And if you have 4 sides, the answer will always be a square because that's how you maximize area. It isn't area length times width. So how do I maximize a product? I make if they have to add up to be a certain total, I make them the same. Everything I just said about Farmer Dave and all that shit, you don't have to know a damn thing about, but I just wanted to see if it sounded familiar to anybody. All right, so those are the 5 that were on the quiz today, right? Those 5 formulas. And then chapter 9, really the only new thing. I mean, you could write this stuff down if you want to again. This isn't new stuff. You can write this down to be really specific. Right, with the S stuff in there. Is that cool? Right. No? Yeah? No? So that's chapter 9, and the only real new formula from chapter 9 was the one with the P stuff in it. And this wasn't even really new either. We sort of Frankenstein that together. Any other formulas you think you should have besides those? Because I've been known to forget something. No, okay. So let me give you guys, while you finish writing that down, here's the answer key for that. Yes, definitely. Oh, like I said a second ago. put that in- Oh, good, good. Here's one more for somebody.
He said it's on the,
I'm just mad because I gotta drive to get a
do you understand?
like an hour away.
Because we have a formula.
So now it's wide open to whatever you guys want to talk about. Yes.
Could you go over real quick, the one when it says like use T-score, Z-score, and nothing? I don't understand like when you would use nothing.
Oh, can somebody tell me a situation where you technically could not do the problem, like a confidence interval or a hypothesis test? Can you create a situation for me? What would have to happen? All right, let's start this way. What has to happen for me to be able to do something?
That is pretty,
You're being a little too specific. The population has to be normally distributed. There's multiple ways for me to figure that out, right? Either I say it is. So don't just see n equal 22 and say, I can't do it, and then leave it blank. I've had somebody do that before. And the last sentence in my thing was, we know that it's normally distributed. That's what I mean by don't just not do it because you think it's some trick. I'm never going to do a trick like that because that would be a little bit more evil than I am right now. Take me in 3 years, maybe I'll be there. Do it. So either I say it's normal, or if it's a means problem, I have to check what? N greater than 30. And if it's a percentage problem, I have to check NP and NQ at least 5. So when do you do nothing? When something breaks down there. So if it's a means problem and it doesn't say it's normal and the sample size is less than 30, you technically can't do that. If it's a percentage problem and one of the NP or NQ is not at least 5, you technically can't do it.
one of them, when it was not normal, you're still able to use T-score, right? Or one of them?
So I think the book flies a little loose sometimes. They do sometimes say at the beginning of a section, assume all the stuff that uses T-scores are normally distributed. But there are a few individual problems where they don't really say it's normal or they don't, but you still do it. You just have to realize, I would never do that to you. I might have a problem that says, why could you not do this? And then I spell it out. And then you have to identify where it broke down. But I'm never going to have, here's a whole hypothesis test, and only a few of you guys are going to realize you don't have to do it. That would be so evil. Does that make sense? So you've got to have one of those things break down, and then the official answer would be you could do nothing. But on the test, especially, if you think you're in that situation, say it maybe, but still do the damn problem because you're wrong. I'm not going to do that. I'm not going to give you a problem that you can't do. Okay. Yes?
On our formula sheet, do we need the equation we just gave us from chapter 10?
Like I said, if you want to do chapter 10 stuff, you could put that formula on your formula sheet. I just don't want to make it efficient and have people write down and then freak themselves out later because they're like, I forgot what that was and do I need to use it? And oh my God. So if you do chapter 10, you want to try it on the bonus, put that on your formula sheet, yeah. Of course, remember, Monday's a holiday. It kind of sucks. Well, it really sucks that Monday's a holiday for us. I'm not saying the reason we're celebrating a holiday is a bad thing. I'm saying it sucks that we have less time for this class. Oh, so you use the Z-score chart. So I use the Z-score chart. 90% or 2% outside. But even if you do this, 2% outside, right? So how much on this side? 0.01. You're close to get to 0.01.
Yeah, I did. I have to be sure I did it.
I would take 233, or 2 through 260, depends on which chart you use, yeah. Oh, yeah.